So today we're going to be talking about the resistor code and understanding what the resistor color code can tell us about the value of the resistor. So why do we need to know this? So manufacturers typically use a color code system for indicating the values of their resistor. And the reason why they do this is because it is very hard to print and read tiny numbers printed on very small round objects. So they've moved to doing this resistor code. And I say moved because it's always been this way. So yeah, this is an easier way, believe it or not, to indicate the value of the resistor than actually trying to print on the resistor what its value is. So let's talk about how this code is set up. So we're going to be dealing with 4-band resistors. So that's going to be resistors that have 4 different color bands on them. There are also 5-band resistors, but we're not going to bother with those today. So the first value shows the first digit. The second value shows the second digit. And this is kind of similar to scientific notation because that third value is then going to be that times 10 to whatever that value is. So it's only sort of like scientific notation because it doesn't have a decimal point. So let's see what this looks like. So here's what a resistor would look like. And you notice how we've got 3 colors put together and then 1 color over on the other side. So that first band shows the first digit. That second band shows the second digit. That third band is that multiplier, so that times 10 to the whatever. And then that fourth band is showing how accurate the resistor is. And that one is going to be a different kind of a color and is always going to be on the right. So this is what allows you to then tell whether or not your resistor is right side up or right side down, wrong side down. Take your pick of language on that one. So you're going to take that other color and put it all the way to the right. So the colors that indicate the tolerance, basically how good, how careful they were in making this, is going to go all the way to the right. So what do these color codes mean? How do we know the value? Well, it's going to be the metallic ones that are all the way to the right. So gold and silver indicate how accurate it is. And gold is plus or minus 5%. Silver is plus or minus 10%. If you don't have any, then that's like 20%, which is very, very rare to see anymore. Usually everything's gold because you can now make these a lot more accurately than you could in long distance pasts. And now there's even 5-band resistors which are then able to show 1% or 2% variation. So we've gotten a lot better at making these over the years, which is good because it's what then makes our cell phones work. So let's then look at how to interpret these colors. So what color corresponds to what number? And we have a chart right here that shows that. So it basically goes black, brown, Roy G. Biv, except for the I because what the heck is indigo, and then gray, white. And then silver, as I was talking about, is plus or minus 10%. Gold is plus or minus 5%. I only very, very rarely run into silver. Most of the resistors that I've ever dealt with are gold, and I'm not sure if I've ever seen one that didn't have a band on it. So it's that plus or minus 20. Now I have run into the brown and red ones that are for the plus or minus 1 or plus or minus 2. All right, so this is now looking at that multiplier. So again, this is going to be times 10 to the value of the color. So 10 to the 0 is equal to 1. 10 to the 1 is equal to 10. 10 to the 2 is equal to 100. So that's going to be multiplying the previous two digits together. And it's like, what on earth does that look like? So let's actually then do a couple of examples on this. So here we have a resistor. So we want to figure out what the value of this resistor is. So first thing we need to do is make sure that the gold band is on the right, because that's going to be telling us that it's right side up. And that gold band is showing the tolerance 5%, which we'll get to. All right, so now we just have to fill in some colors. So brown, that's going to be 1. So brown is 1, black is 0, red is 2, and then this is plus or minus 5%. So we can now put this down together. So this is 10, 1, 0, times 10 to the 2. So this then all makes it into 1,000 ohms, or 1 kiloohm, and then plus or minus 5%. So it could be anywhere between plus 5% or minus 5%, but it's going to be somewhere right around that 1,000 ohm mark. Let's now look at this one. So now we got a different resistor. It's got different colors. We've again set this up so gold is on the right. If gold is ever not on the right, you got to flip it around. So let's see here. Let's throw in some numbers. So we are going to be looking at yellow, and yellow is a 4, and purple is a 7, and orange is a 3. And then this is again going to be plus or minus 5%. So this is going to be 47,000 or 47 kiloohms. And again, tolerance is plus or minus 5. All right, so now let's do example number 3. Here we got another resistor, only now we don't have a gold band, but we do have another metallic band. We went ahead and made sure that that was on the right-hand side of this, and now we can go ahead and pull up our little template and then fill in some colors. So orange is 3, white is 9, green is 5, and then this is going to be for the plus or minus 10%. So it's one of those interesting things that for whatever reason, I, in dealing with my resistors for however long I've been dealing with them, I very rarely run into gray and white. So the values for 8 and 9 seem to me to be relatively rare compared to the black, brown, and Roy G. Biv. But still, 9 is white. We can just look on the table and go, yep, we're good. All right, so now this is going to be 39 times 10 to the 5, or 3,900,000 ohms, or we can say that's 3.9 mega ohms. And mega is, of course, the prefix, the metric prefix for million. All right, so let's look at number 4, and of course, plus or minus 10%. So let's look at number 4. So number 4 is now asking us to go in the reverse direction. So rather than reading a code, it's like, hey, look, what colors do we need to be looking for if we're looking for 27,000 ohms? So this is 27 kiloohms. We need to convert that to 27,000 in order to get all of our digits right. So we're going to be looking for a 2, a 7, and then a 3, for that's the number of zeros we got. So if we pull that up, so let's see, we got red, that's 2, violet, that's 7, and then orange is 3, so this gives us our 2, 7, 3 zeros, or 27 kiloohms. And since it's a resistance of, or tolerance of plus or minus 10%, that's going to be silver. All right, so now let's look at number 5. So we're going to be looking at the color code of this resistor, 1.5 kiloohms, plus or minus 5%. So translate that kiloohms in order to then do this. So 1.5 kiloohms is 1,500 ohms. So we're going to be looking for first one that's got a 1, so that's going to be brown. A 5 is green, and then we've got 2 zeros, and red is for 2. and then we're plus or minus 5%, so that means we're going to be gold. All right, so hopefully that helps you get into the practice and understanding how to read resistors, and then be able to use that in the lab to then pick out and read the actual values of the resistor. This might seem a little bit silly because you could just use a multimeter, but trust me when I say it makes life a lot simpler. So with that, I wish you the very best of days.